Question number 4. What is the probability that a candidate would take less than 200 hours to complete the course?
So I'm gonna do 200, it's gonna be
You
on
need
this
to-
side.
It's going to be on the left side of the car. So you will calculate one z-score for 200.
Mhm.
You already did that, and that came out to be area was 0.1915. Right?
Mhm.
Okay. So, under this normal car, let's forget this one. Draw a new pattern. Okay. This is the car. This is 240. This is 200. And they are saying less than 200 hours. That's the part we need to find out, right? Okay, Shannon, now what do you do? So you calculate the z-score for 200, which gives you which area in this car? The z-score for 200.
Oh, let me get some help.
So I'm kind of with her, so I'm kind of lost too. Is it the Z and then
Anytime you are,
parentheses 200?
yeah,
Right?
yeah, right here, right there. This one was right there.
All right.
Yes.
And then since we know I'm probably gonna say it wrong, the little U thing,
Yeah, mu,
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 mu and sigma.
the mu.
Yes.
So then the mu there would be 200.
No, mu
No,
is
that's
what?
still 240.
Mu is given to you.
Oh, it's still the same. It's always gonna be
Mu
240.
never changes, yes.
Okay.
Population mean, population standard deviation, they never change.
240 minus 200.
No, you gotta put the
You are calculating the z for 200. So your x is 200. So 200 minus 240 divided by the standard
so the
deviation 80.
200
This is right there. We already did that. It's right here.
Yeah, I want to.
But what would you do differently after you get 0.1915?
Okay,
so then
there
I mean, I
comes,
don't have
okay,
that under
there comes your
It's
logic.
going to be that because I was at the.
Next comes your logic based no
So
math.
for example, if another
Why?
problem, this was 500 and this was
Hold on.
70.
Every
that's
time
what
you
we have.
calculate any z-score for any point, what do you calculate? You calculate the distance from the mean to that point.
200.
That point, forget about 200. Any z-score you calculate, that gives you the area under the curve from the mean to that point. It could be from your side, it could be on the left side if the number is less than the mean. If the number is higher than the mean, that will be on the right side. Now here, we found out the area from 200 to 240. So we found out this area.
Right.
But that is not the question. The question is, what is the probability that somebody will need less than this? Meaning this side of the card. And how much is this half of this card? How much? Half of the normal curve is 0.5. So if this half of this curve is 0.5 and this area is 0.1915, this area you have given, you calculated the whole area, you know this, but you need to find out this area which is between the end and 200. So how do you calculate that? No math, logic. Think about it. The question is less than 200.
So
Less than
track
200, that's
0.5.
why you are going to the left of 200. And your half of this curve is 0.5. And the number you calculated for z-score, that gives you this area, which is 0.1915,
Which is 90%.
which is 19% there.
So that means that 19% the probability that the candidates would take less than 200.
No, that's what I thought too, but there's like another step.
No, 0.1915, again, here, let me just draw
Are
it
you
simple.
subtracting 0.5 or dividing by 0.5?
Okay, hold on.
I can only work with vodka. I need a shot and I'll get this quick.
Let's say we have, in this diagram, we have 3 points, A, B, and C. A is the left tail of this normal car. B is this 200, this one B,
Okay.
and then 240 is C. We know from A to C, this total distance is 0.5. We calculated the distance from B to C, which was 0.1915. We don't need this area, we need this area. If you know that this whole thing is 0.5 and this part here to here is 0.1915, how do you calculate this area?
Subtract.
There you go.
that?
There you go. So it will be how much? 0.5 minus 0.1915. Let's see here. 0.5 minus 0.1915. 0.3085. So you can write, round it up to 31%.